so I remember where we're going. All right. What did we leave off with last time? Who remembers? Were we working a problem? Oh, we needed to get back to that problem, didn't we? Because I think I went on a little bit of a tangent, but it was a good one because of the question Austin brought up. We worked through that longer problem.
Yeah, we were.
Yeah, which is good. You guys keep bringing up questions like that if you guys got stuff from the homework that we have. What's that? Today is the 6th. Was it today or the 7th? Today's the 7th? Oh, then I got to set my watch right. Yes, that's right.
Okay, and then another thing before we get started. You said for entrepreneurial that's Thursday, and I saw on the TV screen that it's Tuesday, October 13th. It says Thursday the 15th.
Yeah. That was wrong when we did the Thursday. What I sent you right was for Tuesday.
Okay, so it's in the email.
Yeah, it's in the email.
That's correct. Problem.
Those of you are on there.
I brought the wrong notebook.
Brought the wrong notebook today. I don't know if I've got extra sheets. I will find out. Jason?
Is there any way we can move that assignment back to Friday?
Assignment to Friday. Let's see. So it's 7. We're in chapter 7 is what's due. And we're still wrapping up 7. Today is where we're going to finish. So sure. So I will change that to, what did you want? Friday?
Friday.
Okay.
Yeah, I'm taking all my midterms tomorrow.
Okay. See, now don't say I didn't ever do anything, right? Okay, so we'll plan on Friday for that due date. I'll try to remember. In fact, Jason, I'm going to put it on you to email me so that I change the due date online. Of course, those of you who are crushed by having that due date extended, you can work on it ahead of time. You could do it by the normal scheduled time. Okay, so those of you who are upset about that, you still have the choice to complete it by that time frame. I have increased your choice set, therefore made you better off, is what we've learned in economics. Anytime your choice set is greater, then you are made better off. It's kind of the general rule of thumb. So more choices is better because we assume that you can self-constrain yourself. Now in reality, I've learned that that's not always good, that sometimes we need constraints, but that's a whole different topic. All right, so the answer to your question, Todd, I do not have that, so I will have to, I'll put it up on the screen, and you can copy it down. So we were down on the short one, weren't we? The one at the bottom on the other side. I don't think we had done that, yeah. So if you turn to the last one we did, 7.3, at the bottom of it, down in the corner, is another little problem we're going to tackle. That's the one we're going to start with. I'll put it up here. So Todd, this might not just tell me if, oh, there we go. That's not too bad. So suppose in the long run, total cost function for the firm is that. And the long-run marginal cost function is that. At what levels of output will the firm face economies of scale, diseconomies of scale? Hint, these cost functions yield the typical U-shaped long-run average cost curve. So, first of all, long-run versus short-run. Long-run means what? 2 years, 3 years, 4 years, more than a year? Factors of production are all variable. Long run might be 2 weeks for some companies. Other companies might be 3 years. It does have nothing to do with time. In econ class, long run is the period of time in which all factors of production can be varied, i.e. there's all variable costs in the long run. There are no fixed costs in the long run. The reason we have fixed costs is because we have fixed resources, like our rent payment. If we're in a 5-year contract on our commercial lease, then we've created a fixed cost contractually with our landlord. All right, so long-run total cost, long-run marginal cost. All costs are variable in the long run, so the LTC and the LVC are really one and the same thing. There are no fixed costs. Economies of scale. Anybody remember what that thing is? What makes economies of scale? Producing more. So as you increase the scale of production,
Cost decrease on average.
cost on average decrease, right? So and it's actually specifically tied to long run costs. Long run average costs decrease. So using the information in the problem, go to work. I'll write down a couple of those things. So that we just mentioned. So note, in the long run, all costs are variable. Economies of scale. I'll give you the shorthand notation. Economies of scale. An increase in quantity creates decreasing long-run average total cost. So start with that hint and a graph is what I'd recommend. These cost functions yield a typical U-shaped long-run average total cost curve. Any little mask over here? Have you been to the doctor? So, picture for this one's really going to be this, right? So use that intersection. And then how do you figure out that one? We're going to use the same concept. Okay, yeah. You draw the marginal next time. I'll have a pretty little graph first. Right. There you go. Except this doesn't exist. Remember? So this one's a little bit different that we're looking at the long run so that there is no average variable cost. Well, there is in the sense that it's the same as the average total. Your answer ready? You just got to figure it out. Yeah, good. I like your picture there. And you got to solve the equations. So this sucker doesn't exist.
Yeah, that was already there.
Oh, okay.
And I don't have space.
You don't have space. You don't have the eraser. Okay. As long as maybe you should draw a fake or.
This is like a
invisible.
mini one right here.
Oh yeah, that's fine. Okay. Okay, well, that's good. All right, so you on track of how you're calculating that. You got the total, right? So then, how do you make that the average? As a little side bonus, how do we know that that this cost function is indeed a long run cost function. What's one little thing that you could look at that says that this cost function, the way it's written out in its functional form, is indeed a long run cost function? How do you kind of know that?
Q with every.
Yeah, it's got Q in every expression, right? So there's no fixed constant term. So it's all variable. Depending on how much you make, it changes. You got 150? I hear 150. Anybody else hear 150? Here, yes. You got something different?
167.24.
167.24.
204.
What'd you get?
204.
204. So we got lots of fun going on here. 204. Anybody else? Well, I don't like this. Is why I wanted to maybe interrupt. You don't need to. You shouldn't be needing to do that part. I don't think. Oh, wait, maybe you did. You shouldn't need to do that. So if you take back up, where'd you send me? Oh, you sent me. So you got to help me on these things by making sure you label. I like this. Where's your average total cost function? Oh, you haven't done it? Oh, so that'd be your first step. So there's this one. All you're doing is dividing that by Q. And I've got it written. Because this is really simple, right? It just divide this by Q, divide this by Q, divide this by Q, and then it turns into what I got written up on the board. Yeah, I have that there. Okay. Except for this minus thing. So if you put them equal to each other, then set that equal, things will collapse down.
Yeah, I was like,
Okay. Yeah, so that's this one. Yeah. So that looks good. So now we set this equation equal to this equation. Right? So that's all we're doing with it. So you got this setting equal. So did we have consensus after 3 different answers? Oh, I see an eraser coming out. Okay, that one all of a sudden disappeared. What did you look at?
I originally did that one.
You got 150. Okay. So, which one are we at here? 150 or 204? 150. 204. Who's my 204 person?
That's because I didn't do the long run average total cost.
Ah, okay. So, if we set this equation equal to this one, a lot of stuff starts canceling, right, and dropping out. So it's not the Q squareds and all of that starts kind of getting a little bit easier. Q equals 150 after you solve for Q there. Which doesn't quite answer the question yet. Sorry, Todd. Okay. Which doesn't quite answer the question. At what levels of output will the firm face economies of scale? 0 to 150 would be the right way to answer this, right? So we just found the quantity equal to 150. So to really directly answer this, at what levels does that happen? And I saw you guys had some good pictures looking like this: long run marginal cost, long run average total cost. That intersection point is what we just solved for, 150. And so we have declining average total cost going up from 0 to 150. This is our economies of scale. And then, of course, it starts to turn up and average costs start climbing, which is our diseconomies of scale over this range. Okay, questions on that?
What is it at right at 1?
You know, it's just kind of a turning point. So there is a.
It won't be economy for this.
Right. It's just right at, yeah. It's a turning point. It is possible. Again, it would be a weird looking function, but you could. Sometimes I've explained it this way in principles class, like it's declining, and then let's say it goes totally flat.
Yeah.
And then it goes up. You know, then it would be, you're usually in a constant returns to scale type of thing, but returns to scale is actually with the quantities. Double. Remember when we did double the input, double the output, or double, you know, so it's really just kind of a flat spot. But this would not be diseconomies or economies. It's just kind of constant economies. All right. And that's why the question with saying the range is that up to 150 we'd experience economies. Because even if we're at 149, there's still a little bit of economies of scale with the 150, right? It's still going down, but now the 151st, it starts to turn up on us. Okay, anything else there? Let's see, where did I write this? I guess I have it flipped over here. So we got Steve and some solar power here. Steve and Son's solar power panels has a production function of Q equals 4KL, where marginal product equals this and marginal product capital equals this. The current wage rate is 8, the rental rate is 10. In the short run, the plant's capital stock is fixed at 10. What is the cost the firm faces if it wants to produce 200 units? So if it wants to produce 200 units, what is the cost the firm faces? So from what I talked about last time, what's going on in your head? Please don't tell me nothing, but if that's true, let's just face reality. Labor, capital, Isoquant, Isocost, what's going on in your head? Graphically, going on in your head. Isocost is a straight line, that's correct. And its slope is fixed at, this is chapter 6 stuff.
Marginal rate of change.
Nope, that's on isoquants. So what's the other one? The other side of the equation? So Austin was starting to say the wrong thing. It's the right thing for a different question, but it's the wrong thing here. The what was it, Tig? Wage over the rent, right. The price of labor over the price of capital is the slope of the isocost line. In equilibrium, I already put an equal sign, so I kind of gave this away. In equilibrium, the optimal point, these two things are equal to each other. This is the slope of the isoquant. Okay, so we're getting a little closer here. So on this graph, given what the words are in this thing, talk to me in terms of isoquant language and cost minimization language. What does that look like graphically? And somebody already said the isocost is a straight line. That's right. It's a straight line with the slope of this. What does the isoquant look like? How many of them are there? There's an infinite number of them. How many, if I was going to do this problem graphically, how many would I want to draw? 1. And what level of production does it represent? 200. There's an infinite number of them. Here's quantity number 1, 2, 3, 4, 5, samurai sword. 200 is one of them. Take that section from the production function in 3-dimensional space, drop it straight down to the floor in 2-dimensional space of K and L. That samurai sword is a slice of the production function at a quantity of 200. So we have a fixed quantity, and being the little profit maximizers that we are, now that we know we want to make 200 units, I want to do it as cheaply as possible. Where does that happen? How much labor and capital and what proportion of labor and capital should I use? Oh, well, that's easy. That depends on the wage rate and rental rate. If the wage rate is $2,000 an hour and I can pick up a machine for $2 an hour, it's likely that I should probably have a more capital intensive production method, right? I should have a more capital intensive production method. If labor is $2,000 an hour and I can pick up a machine for a couple bucks an hour, on the flip side, if I can pick up human beings cheap at $7.50 an hour and a machine runs $2 million, I probably want to start thinking about how I can make my 200 units with a lot of labor and a little bit of capital, right? That's what this process is doing for us, is letting the math work itself out. How can I minimize cost for a given wage rate and rental rate? Which cost would I like to be on? All of these isocost lines represent a little bit different type of cost. Which one do you think I'd like to be as a profit maximizer? Which one would I want to be on? 1, 2, 3, or 4? Kind of a loaded question. Good, Michael, I like your response. 2. Why not 1? 1 is better, isn't it? 1 is smaller cost. What's wrong with 1? It's not on the isoquant, right? Is it possible for me to make 200 units and only spend this much money? Is it possible for me to make 200 units and only spend this much money? No, it's impossible. The isoquant, the isocost line tells us all the possible quantities I can produce by spending that much money. You have to spend more money, but I don't want to spend more than I have to. I know, I've got the solution for you. There is the smallest cost possible right here, where the slope of the isocost line is equal to the slope of the isoquant. Hire that many units of capital and that many units of labor, and you will have minimized cost. You chose the smallest cost possible given these constraints. Okay, so we threw another ringer on you into this problem, right? What was the ringer that we threw on? What was the ringer here in A with the question? That could constrain you a little bit. K is fixed at 10. If capital's fixed at 10, we might not be perfectly at that long run point when I have the opportunity to adjust the amount of capital, right? So how can we approach this problem now? I'm stuck with 10 units of capital. I know that I want to produce 200 units. What did you come up with? Okay, so back on the production function. All right, what did you do?
Q equals 4KL Plug in the 200 Q and solve for L.
All right, so 200 is where we need to be. Times 4 times 10. Do we have many choices here on how to get 200? We're actually minimizing labor. We're using the least amount of labor possible to get to 200. So with that, we solve for L, and L equaled what? 5. So we got 5 units of labor. All right, questions about that? What will the firm wish to do in the long run to minimize the cost of producing 200? What's that? Oh, yeah, that's right. We were, thank you. Yeah, we had to calculate the cost. So then, what do we do next? Yeah, to this cost equation. So remember, sometimes we have cost equations that look like this, or cost equations that look like this. What's the difference? What's going on here? Sometimes cost equations look like this. Sometimes cost equations look like this. That's kind of weird.
Those are in terms of quality.
Okay, those are in terms of quantities. I heard Jason start first, but you were behind, so Austin couldn't see that. What were you going to say, Jason? Okay, so Austin said those are in terms of quantity. And what's true of the other one? In terms of what, Todd?
Variables.
Variables, yeah. What particular variables? Let's be a little more specific. Labor and capital, which are, what do we call those in general? Not trying to be funny, I'm just trying to make sure we're thinking about things. Inputs and outputs, right? So in our production process, so our production function is this. What does the production function tell us? It says, hey, go out and get 46 people and 10 machines, and you can get yourself this many units of output. Inputs lead to output. Well, what it costs me? Well, I can express that cost at the end of the day as a function of quantity being produced, or I can drill down deeper. I can drill down deeper to the inputs that created the output. Check this out. Just for fun, we didn't have this in this problem, but since it's on the board, I'm going to exploit the resources at my disposal. How can I make this cost function that's currently a function of output a function of inputs?
Plug 4KL.
Plug 4KL in there, right? So this tells us how hamburgers are produced. So I put in 4KL, 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 and whatever that ugly sucker turns out to be, it's a function now of labor and capital, right? We got rid of the Q's, just like what we're doing down here. So it's possible to go back and forth. Any questions on that? So when we get into this profit maximization stuff, which we're going to continue to do going into chapter 8 and 9 and probably on out to 11, I can't remember, is to start keeping 2 things separate for yourselves in your brains. Production functions and isoquants, right, is kind of the connection. There's a connection between this and this. And then these cost functions, which can be expressed possibly as a function of output, but can always be put back as a function of input if you've got the production function. All right, so now back to this question. Here's our cost function, wage, labor. We've got all of these variables. What's our wage again? $8 times our labor of 5 plus our rental rate of what? 10 times our capital of 10. So 100 times 8 times 5 is 40, $140 worth of costs. Right? Phew! All right, so this cost function, given our constraint, gives us 140. All right, now back to part B here. minimizing the cost of producing 200. How much will the firm save? Hint, you may have to review chapter 6. So, what'd you guys come up with? Oops, I shouldn't have erased this. Maybe I might need that. But how much? They saved $16?
Yeah, I rounded.
Okay, so saves $16. And what did you do to do that though? How did they save $16?
They gave up more capital and they got more.
Okay, they did a substitution of capital for labor. That isoquant allows us to do more labor and less capital, or more capital and more labor, and so we can reorganize it. In the long run, we can alter our units of capital to be optimal along with the amount of labor, and so when we run through that process, we get different numbers. So now, what are those different numbers? How did you get that?
Started by moving the four marginal products.
The marginal rate of technical substitution? That thing? So that sucker equals the marginal product of labor over the marginal product of capital. And that equaled, they give this to you up in the problem, right? We've got 4K over 4L. The L is canceled. We got this little K over L business going. We're going to set that sucker equal to
The wage rate.
wage rate over the rental rate. The wage rate was $8. Capital can be bought at 10. So the wage rate is 8 over 10.
And then we solved for capital.
Solve for capital. Okay, so notice we got K over L equal to 8 over 10. You solve for capital, but we could solve for labor, right? Just to be clear. Right. So yeah, it doesn't matter which way you solve, but you solve for K. I'm just going to follow your line of reasoning here. So we get K equals 8L over 10, or 8/10 L, or however we want to do that. Okay, where'd you go from here?
Put that into the production function.
Okay, so you put that into the production function. Q equals 4 times K, but now I'm going to put 8/10 L times L, right?
200 in for Q.
And 200 in for Q, okay? So let me just do that. Well, I'll do that in 2 steps here. So Q equals 200. This thing collapsed down to what? 32/10 L squared. And then you ended up getting into a square root thing, right? Which is kind of weird. So don't be afraid of square roots. We might find some of those. So L squared equals, let me think here, see if I can screw this up, 2,000 over 10, 32, times nothing. Am I right?
We divided by 4 earlier, so
Okay.
we did over this.
But did I do this? Is this legitimate math here? I got the 10, flip that over, 2,000 divided by 32. I think I did it right. I could use a calculator, a little backup, but. And now we take the square root, and we get L equals 7.91.
So we have to round that to 8 because we can't have fractional units of labor.
It depends on what the problem asks for. So I would, did it say that we had that?
Well,
It says it's flexible, and sometimes this looks inflexible, but if we're measuring capital units in hundreds or thousands or something, then all of a sudden this turns into 791 units. So be careful with that, unless the problem explicitly states it. So we're going to go with a, what's that?
leave it as.
Yeah, leave it as a decimal. Yeah. So 7.91.
Put that back into the capital function.
Now we go back into the capital function. So you brought it back up to which one? Here?
Yeah.
Okay. So that's one way to do it. Sometimes there's a couple ways to skin the cat here, but that works out just fine and gives you K equals 8/10 times L, which is 7.91, and that gave you a K of 6.33?
Yeah.
Okay. All right, so what will the firm do to minimize this? How much will the firm save? So how'd you get your final savings, Jason? Just to let you run this baby out.
Put it back into the total cost.
Okay, so the total cost function, we've got a wage rate of $8. We now have labor at 7.91, plus my rental rate of $10 times my new amount of capital is 6.33. And that gives me, what do you got here? $126.58? $126.58. And then we saved compared to our old cost. Our old cost was 140, is what we calculated before. And sure enough, we've saved now 140 minus 126.58. Which is a little less than maybe what you said. Did you do that backwards? Oh, you had to round it. Okay, yeah. So $13.42. So TC1 minus TC2, if we want to think of it that way, we have a negative 13.42. So we saved $13.42. Whew! All right. Exciting stuff. Questions on that? So that turned out to be kind of similar to the problem we wrapped up with last time, right? Or we used kind of some of the same tools. We reached into the same toolbox. So graphically now, remember, K star and L star, if we were to graph this thing out, 7.91, this is at 6.33. And how would you draw, last little challenge, I know we're about out of time, but how would you draw this savings bit? Where does the $140 belong? Where would you draw that? Where would that be relative to this graph? I've got my K star, L star, just inside, right? So I'm spending just a little bit more to make 200, and am I at actually point A or B? A, right? Because A had where we were at 10 units of capital, and we were at 5 units of labor. Good. All right? Let's call it a day there. We'll see you on Friday.